Hello everyone, in this video we are working on the question number 5, working on using the exponential smoothing model to forecast the gasoline price. And then for the smoothing constant, basically our alpha here is equal to 0.2. And we're going to look at how can we use Excel to do the exponential smoothing with the smoothing constant equal to 0.2. And then calculate MAE, MSE, MAPE. And then at the end, we're going to do a comparison between what we have from question number 3 and the 4, and also this question number 5 to decide which model actually give us the best prediction for the gasoline price. Okay, let's look at our data first. Okay, so basically these are our 22 weeks of the gasoline price. And then we're going to do is forecasting also the data currently on the spreadsheets from the last practice video that is about the moving average with 3 periods. Now let's look at how can we using the exponential smoothing. Okay, so the same place under our data tab, there is option called the data analysis. So under the data analysis, we will choose the one called exponential smoothing. So which is this option, exponential smoothing. And after you do that, you click OK. So first of all, you need to tell computer where is the data. So for the input range here, I will select from my B2 to B23 because that's where my original data, actual data located. And then the second is the damping factors. So this is a very important one. You make sure you get it right. So based on these problems, our smoothing constant, which is also our value for alpha, equal to 0.2. So on Excel, the damping factor here actually is not alpha. It is 1 minus alpha. So therefore, in this case, the alpha equal to 0.2. What you need to do is to do a calculation, 1 minus 0.2, and we got 0.8. So therefore, we put a 0.8 here. And then my output range, so I will put in at so for my output range, and then I will put at the forecasting F here, and then click this arrow, and then I will including the chart output, so I can including the line time series line chart, and then click OK. It is okay, so they are generating the chart. Okay, here they go. Okay, so this is my forecasting, the exponential smoothing. With alpha equal to 0.2. Okay, now as you notice that the other column already updated because based on my video on how to calculating the MAPE, MSE, and MAE, I already set it up. And so basically I first calculate the arrow, finding the differences between the actual value and the forecasting value. And then I square them, I got absolute arrow. And then I take it, I take absolute value, I call the absolute arrow, and then take the square the absolute value, I call the square arrow. And at the end here, I'm using the absolute arrow divided by the actual value times 100. That's giving me the absolute percentage arrow. Okay, so now based on the value in column E, and I'm able to calculating MAE, and based on the column F, and I'm able to calculate the value for MSE, and based on the value in G, and I'm able to calculating MAPE. So here, again, if you do not know how to set up the value in EFG, please watch the previous video. So now let's see what is the value for MAE. So I'm using average equal to average parentheses, and I will select value under the absolute arrow, and I select all of them, and then close the parentheses and push enter. And then so that gives me the value for MAE. For the MSE, I use average again. And then I will select square the arrow column, and then close the parentheses, and then push enter. So for the MAPE, the same, average. And then select my last column, absolute percent arrow. And then close the parentheses. Okay. So, for the exponential smoothing with smoothing constant 0.2, I got MAE equal to 4.01 or 4.02, and then for the MSE is 27.06 4. And then the next one is MAPE is 15.26. Okay, so now I have the MSE, MAPE, MAE for all 3 models. So which model did the best job to forecasting the gasoline price? So we just need to find the model that give us the smallest value that is for measuring accuracy, right? So based on MAE, the smallest value we got is a moving average with 3 period. And then let me highlight this one. Based on MSE, and then the best value we got here is, let's see, this one. And then for MAPE, the smallest value is this. So basically, based on MAE, we will pick a moving average with 3 period times. And based on MSE, we will pick naive forecasting. And for based on the MAPE, and we'll pick moving average with 3 period time. Okay, so that is how you've identified the best model. So although we see a little bit disagreement among the 3 measurement to measure accuracy, and then so you can try out naive and MA with a period time. So that is how you can do the exponential smoothing. The most important part is make sure you identify your damping factor correctly.